Hey, what's up guys? Today we are going to go over the basics of snake genetics. For this video, I will be using Tom and Tina, my two jungle carpet pythons, one being a normal jungle with good genetics and purity coming from Brandon Wheeler over at Morelia House. Check him out on Instagram. And the other snake being from a random wholesaler who won't divulge the genetic heritage of the snake, leading me to believe, based off the color and pattern, that he's a jungle with some Irian Jaya mixed in. So, the key principle of genetics is to understand that any trait, whether it's good or it's bad, is produced by one or more than one pair of what are called alleles. Alleles are one or more versions of a gene. Before getting into the Punnett squares, I actually kind of want to talk about a couple different words pertaining to genetics. So, starting off, dominant allele. So, put simply, the dominant allele is the trait that the animal exhibits physically. The recessive allele is a recessive allele will basically only be visible if paired with another recessive allele, making it dominant. Homozygous, or having two paired alleles of the same case, showing whether the alleles are dominant traits or recessive traits. Being the same, the trait will be expressed visually. Heterozygous, having two pairs of alleles of different cases, meaning the trait will not be expressed visibly. So, the Punnett square. What is a Punnett square? It is a scientific method of identifying genetic traits of the offspring of two separate animals. When a parent with AA, or two capital A's, two lowercase a's, however you want to put it, being Tina. She is a normal, strong genetic jungle carpet python, and she tried mating with, for educational purpose sakes, say that Tom is just not a jungle, he's just a Papuan. I'll display up on the screen a Punnett square showing the two parents, one represented with two capital A's, one with two lowercase a's. Capitals being the jungle carpet python, or Tina, and the lowercase one being the Papuan example, or Tom. The alleles of both parents are combined in the lower portions of the Punnett square, making all the children. So, a capital A and a lowercase a, meaning that they are all visually normal jungle carpet pythons, but they are het for Papuan, or just showing Papuan characteristics and traits. Now, if we take one of them dang kids and you combine it with another one of them dang kids, both of them being jungle carpet pythons, het for IJ, Irian Jaya, or Papuan, this is what you get. So basically, you get 25% of the offspring being completely normal, jungle carpet python look. Then we're gonna have 50% that are het for Papuan, or are kind of like, in terms of carpet pythons, it's kind of a cross, but ignoring the Morelia complex, the final 25% of the offspring will be homozygous for this combination, this morph, if you will. Realistically, it's hybridized, but ignoring the Morelia complex, we're talking morphs here. So 25% are going to be normal, just like Tina. Then 50% are going to be normal, but het for the morph. And that will be animals that also look like Tina. And the final 25% of the offspring being homozygous, those are all, basically going to come out looking like Tom. This leads me to the final Punnett square that I want to talk to you guys about. So this here is a display of a animal that is homozygous for the recessive trait. So Tom. So he displays the traits, the attributes, the pattern, the coloring of the genetic morph. And if we combine him with, say, a visual normal jungle, but they are het for the morph, this is what you get. You get 50% of the offspring being a visible combination of the recessive homozygous trait, which means that 50% are going to look like Tom. The other 50% are going to be het for the trait, so they are most likely going to look like a normal jungle carpet python. So yeah, that was basic snake genetics, and I hope you guys enjoyed the video. Please don't forget to like, comment, and subscribe. Helps with the algorithm, helps people view these videos, and helps me have the ability to reach out and educate people that may not know the basics of snake genetics or just animal genetics in general. Anyways, I'm Nick from Nick's Reptile World, and I will catch you guys later.